It's your friendly math tutor, Miss C here, to solve systems of equations by graphing. So our first step is going to be getting these equations in slope-intercept form. As a reminder, that's y equals mx plus b, where m is the slope and b is the y-intercept. And then we are going to graph these and find where they intersect or where the lines cross. So let's go ahead and jump in to 2x plus 3y equals negative 21. Our goal is to get y by itself, just like we see in this equation. So the first step in that is getting the term that contains y by itself. So we're going to get rid of this 2x by moving it to the other side. We're going to subtract it from both sides. If we do that right, we should get a 0 where 2x currently is. 2x minus 2x is 0, plus 3y leaves us with 3y, which was our goal. And then negative 21 and negative 2x are unlike terms. That means they can't be combined, so this is correct. Now we have to get y by itself. So 3 multiplied by y, the way we disconnect them is by doing the opposite of multiplication, which is division. So I'm going to divide by 3 on this side, and I'm going to divide by 3 on this side. So when I do that, I get a y here because 3 divided by 3 is 1. 1 times y is y. This 3 on the right side gets divided by every term. So negative 21 divided by 3 is negative 7. And negative 2x divided by 3 is negative 2x over 3, or negative 2/3 x, or negative 2/3 x. Okay, so our y-intercept is negative 7. Our slope is negative 2 over 3. That means we are going to go down 2 for our slope, and we're going to run to the right 3, or we're going to go up 2 and we're going to run to the left 3. So when we have a negative slope, one of the movements has to be positive, one of the movements has to be negative. So let's have a look. We start by plotting our y-intercept first, which is negative 7. There we go. And now we're going to run rise and run negative 2/3. So we're going to go down 2 and over to the right 3. But I've run out of room on my graph, so this is now where we're going to rise to and then run to the left 3. So still one positive movement, one negative movement. There we go. We're going to rise 2 and run 3 to the left. And we have our 4 points. We're plotting extra points here because we have to be extra accurate with our line since we're trying to find an intersection point. And now I'm just going to use a ruler and connect these. And there is our line. If you're following along with me using a practice sheet in your classroom, you know that if my line goes through this coffee cup, or if you have the worksheet that has the heart or the football on it, that means you graphed this line correctly. Awesome job. All right, so now let's look at our second equation. So we have 4x minus 6y equals 18. I guess I should say this is number 3, which hopefully you see in the left-hand corner. Same process, we're going to get y by itself, so I'm going to subtract 4x from both sides. That leaves me with negative 6y equals 18 minus 4x. Again, we are not combining the right side because we can't. They're not like terms. All right, to undo the multiplication of negative 6 multiplied by y, I'm going to unmultiply, also known as divide, by negative 6 on the left. I'm going to divide by negative 6 on the right. You can show multiplication or division this way as well, as a solid line like we did above, or as 2 separate fractions. It's the same thing. So here we have y, because negative 6 divided by negative 6 is 1. 1 times y is y. 18 divided by negative 6 is negative 3. And then we have 2 negatives. 2 negatives make a positive. And then 4 over 6 is a fine slope, but they're both divisible by 2. So I'm going to actually say it's 2 over 3 is my slope, because 4 divided by 2 gives me 2. 6 divided by 2 gives me 3, and then times x. So our slope is negative 3, or our slope is positive 2/3, and our y-intercept is negative 3. So for our slope, that means we're going to go up 2 and to the right 3, right? Or because it's positive, we could go down 2 and to the left 3. 2 negatives make a positive. That's why that works. So let's go ahead and plot our y-intercept here. Oh, that's not our y-intercept. Our y-intercept is right there at negative 3. Sorry about that. And then we're going to go up 2 and to the right 3, which is that point you just saw. We're going to do it again, up 2 to the right 3. Ooh, we hit our coffee cup. That's a good sign. We can do it one more time, up 2 to the right 3. And now we're going to use a ruler to connect these lines. All right, When we do that, I can see that my lines meet right here. That point, I'm going to count over 1, 2, 3 to the left. So that's -3 is our point of x coordinate of our point of intersection. And then we are down to -5. So our point of intersection is -3, -5. This is the solution to this problem. And the reason we say that is because this is the only point on the graph that is true for both equations. So if I plug -3 in for x and -5 in for y in both equations, it would make the equation true. This is the one and only point that does that. So that's the point of doing this. All right, thanks for joining me. Till next time, you've got this.